Welcome to a model steam engine test plant. This is part 6. Practice makes perfect when doing things by eye. The more you do it, the easier it becomes. Marking out and drilling the mounting holes in the tank bases, then cleaning the edges and rounding the corners. I would like to point out before I start, these videos are made for beginners and intermediates, so if you're an expert engineer, you shouldn't need to watch this sort of thing. There are many different approaches to drilling multiple holes in the corners of pieces of metal. This is just one of them, and it's possibly not the best method, but it's one of the quickest. I'm using a washer, and I hold this on the corner of the piece of metal, but to make sure that I'm not making a mistake, I draw a cross on it like this. Although really, the cross is not 100% accurate. I would go by the feel of the washer against the metal rather than the position of the line. I hold the washer in place and simply mark the centre point with a felt tip pen. Then I do exactly the same on the larger tank base. And now, as you can clearly see, I end up with two pieces of metal with marks that are fairly accurately in the corners. Not possibly the best method if you're going to bolt the two pieces of metal together, but in this case I'm not. These tank bases will be eventually screwed down to the baseboard, and that's the only function of the holes. Over now to the drilling machine, and I'm not even using a centre drill. I'm doing this entirely by eye. I am using a bit of a technique though, I'd better mention it. First of all, I gently touch the drill point on one of the black spots, then I have a look at it to see whether the shiny bit is in the middle, and if it is, then I do it again and go all the way through. I'm drilling these holes 9/64 of an inch, which is clearance size for 4BA. There is another way to do this if you're not so sure, and that is to drill the hole 1/8, which is not clearance size for 4BA. Then if you get it wrong, you can use a round needle file to put the hole in the right place, but I'm not going to do that. I'm doing it the easy way. After the drilling, it's time for deburring. I'm using a larger twist drill just to remove the burrs around the edges of the drilled holes. No power required here, you just turn the twist drill between your fingers. These two pieces of brass have a protective piece of film on the other side, as they are designed to be either brushed or polished. After removing the film, I deburred the holes. The shiny part of this brass is the underside of the tank. The other side that I drew on with a felt tip pen is going to be the top side. That's one done, now for the other one. This part of the sequence is exactly the same as the one you've just seen, except for the size of the piece of brass. And here we see Sod's law, or the chaos theory, in practice. It nearly came off in one, but it left a bit on the corner. It was easily removed, and here I'm continuing with the deburring process on the underside. When deburring using a twist drill, you need to use a fairly large twist drill. If it's too small, it won't deburr very well. The drill bit needs to be big enough so you can grip it and rotate it fairly fast with some force just using your hand. I could use a countersink in the chuck of my drilling machine, but once again, doing it this way is much quicker. Now the holes are all drilled and deburred, I'm using the washer again. I'm holding it back in position with the hole in the centre and using the felt tip pen to make a mark on every corner. Once again, this is not precision engineering, but this is not a precision part. After marking the corner positions of both of the pieces of brass, I took them into the outer part of the workshop and I'm using the 1-inch belt sander to round the corners as shown. I'm being very careful not to go past the line. There's a reason for this, I'll show you that shortly. Using this method is very quick, and in no time at all, every corner was rounded. I didn't grind the marks away completely because there's a bit more cleaning up to do. And I will need to know how much pressure to put on this part to remove these corners and clean up the sides. That's because for this job I'm using my 4-inch belt sander, which is far more brutal than the 1-inch one. It's really important to make sure that you control the metal and not the belt sander. The belt sander will always try to grab it and remove too much metal. Don't let it do this. And it's worth bearing in mind that the belt sander seems to trim more off at the front, any piece of metal held on the belt that faces the right hand side. In this clip I'm finishing off the corners, and by doing it this way it looks a lot better because I'm only holding it very gently against the belt sander, and it gives the edge a nice brushed finish. I cannot stress enough how gentle you have to be with these parts. Here I'm cleaning the edges of both sides on both pieces of metal. There is of course a better way of doing the job using a milling machine, with a milling cutter like this, fitted to an R8 collet in the spindle of my milling machine as shown here. To round the bases of the corners very accurately I would use this method, which is the same one that I would use to round locomotive coupling rods and connecting rod ends. This is the chuck of my rotary table on the milling machine, and the 9/64 drill bit that I used to drill the holes is now in the chuck jaws, with just the drill shank sticking out of the chuck. When doing a job using a rotary table, it's really important to put something like a washer on first to give some clearance for the milling cutter, otherwise you would risk machining the top of your jaws. Here I'm indicating the direction of rotation of the cutter. This is very important. You must always turn the piece of metal towards the cutter and never in the direction of the cutter. If the cutter grabs the piece of metal that you're holding manually against it, it will be ruined. A better idea to do this job is to use a bolt with a parallel shank. That way the head of the bolt will stop the part you're working on from working its way up the bolt. The whole point of this episode is to show the type of results that you can get by eye if you practice. To conclude, here's a quick health and safety warning. To drill the holes in these pieces of brass, I used a very small twist drill of only 9/64 of an inch in diameter. And had this small twist drill grabbed in the brass, it would not have spun the piece of brass around. Had I have needed the holes to be larger, then I would have done it in a different way, by positioning the piece of brass loosely between the jaws of the machine vise on the drilling machine. I'm continuing with the scoring of the part because it's going to be painted eventually. And here's the lower part of the water tank sat on the base. That's it for this episode. Stay safe, stay healthy. Thanks for watching, and I hope you found it useful. Please take the time to visit my Mainsteam Models website and click on the section of the website that says Video Playlists. And by doing that, you can find other videos that you may like to watch. And by using the playlists, you can actually watch the videos back to back.